get started here. Okay. So I'm going to ask a few thought questions, and you guys can just shout out your answers if you know them. These are coming from the back of the book, and they are the kind of questions that you would be able to answer easily had you read this chapter, which you almost certainly didn't. Let's see now. Can a class be static? This is a yes or no question. The answer is yes. Right? How would you make a static class? Well, if it's a top-level class, could it be static? Here, I'll just I'll do what you told me to do. Here's a class. Now, what can I do? Public static. I could just put it right in here, right? Static, and oh, wait a minute. That's not right. There's something wrong here. Just a minute. Static. Oh, it doesn't like it. That's what you told me to do, right? Yeah, you can't do that. Compilers won't compile it. It says something. It says modifier static not allowed. So you can't do that. So can a class be static? No. You're wrong again. A class can be static, but a top-level class cannot be static. So a top-level class is a class which can be used to contain other classes, or is sometimes called the outer class. So if you have a class inside of a class, that class can be static. So let's make some nested reference data type examples. We'll do a nice example here. We'll make a new class. We'll call it the static class example. So now we'll make a static class. And what we'll do is here's a class called the static class example, and inside of that class we'll have a static class called the Brian class, and that is permitted. You can have a static class called the Brian class, but it has to be inside of another class. So now suppose you're inside the Brian class and you want to make another class. Can that class be static?
I would say yeah.
Sure. So now I'll have another static class, and we'll call this class the Arodi class. And now the Arodi class is a static class contained in the Brian class. Now, tell me, is the static class example static or is it dynamic? Is the static class example, which is a class, is that a static class or a dynamic class?
Well, dynamic.
It's a dynamic class.
Static classes.
Why is it a dynamic class? Oops. Why? Why is the static class example considered to be a dynamic class? You're correct, by the way. It is a dynamic. It's not only because it's missing this static modifier, it's because it doesn't really exist until runtime, when it has to be instanced. So it has to be instanced dynamically. So dynamic memory elements are instanced at runtime. That's what makes them dynamic. Static memory elements exist at compile time. That's what makes them static. So let's think about this. I can't really make reference to the static class example except as a container of static methods. So what I could do is I could go into the Brian class and I could invoke a static method inside of the Brian class. For example, public static hi. And what it does is it prints out, quote, hello world. And if it's giving me a hard time, it's because it doesn't return anything. You've got to have public static void hi, and now it's fine. So now I've got a static method in a static class in a dynamic class. And what I can do is I can make direct reference to the static method. And what I do to do that is I say static class example dot Brian dot hi. And that will allow me to gain direct access to the hi method in the static Brian class contained by the dynamic static class example.
Quick question. The private modifier, can you still get access it in this example?
Yes, because this method has access to, well, if private is for, it depends, what are you going to make private?
Static high.
The high? I don't know. That's a good question. Yeah, he lets you do it. I thought you could. You have to be outside of the class before you get a problem with that. You're inside the class, you have privilege. So that's perfectly acceptable. But what about a dynamic method inside of the static class example? Public void hi s out control J enter. What shall we call this? Hello CR320. How's that? So now, how can I invoke the hi method in the static class example? Can I just invoke it directly? Anyone? Yeah, that's. Can I just say hi? And the answer is no. What if I don't? What if I don't say static class example? What if I just say hi? Yeah, hi. He doesn't like that because I'm in a static method. Main is static. So I need to make a new instance of the dynamic class. New static class example. And now I can say hi. Oops. And that is a completely different method. And it says hello CR320. So that's a named static inner class held by a named dynamic outer class. But what would happen if I wanted to make an anonymous static inner class? How would I do that? Well, class Brian is a reference data type. And one thing I could do with class Brian is I could make a Brian instance, Brian B equals new Brian, and I can alter the way that Brian instance is implemented. And I can do that by shadowing the static hi method. And what I can do is I can say private static void hi, and will he let me do it? Inner classes cannot have static declarations. How about that? So I'll make a new one here. He's okay with that. Now if I say S out, Control J, enter, I should be able to change how this works. And so this is my anonymous inner class. How's that grab you? So now if I say b.hi, is it going to print hello world, or is it going to print anonymous inner class? Yeah, it should do. So static class example, which I made a new instance of here, I should probably introduce a variable for. So what I'll do is I'll extract a variable, and then what I'll do is I'll go to my static class example, and I've already invoked hi, but I haven't invoked b.hi. So now .b.hi, and what does that do? Something completely different. All right? Let's see. Ah, how about that? Were we expecting that? B.hi says anonymous inner class, but it doesn't look like it invoked it, right? What happened? It invoked the static instead. So if I said hi hi or hi 2, what would that do for me? Oh, because it's private. Hey, I gotta make this public. That shouldn't matter. Let's try hi 2. He doesn't even like that. What could be the problem? Brian B.hi 2? What's his issue here? Couldn't find method hi 2, but he liked hi. So why can't b.hi 2 work? Oh, because Brian doesn't have a hi 2 method in it. It only has a hi method in it. And we cast it to Brian, so that method got disappeared.
Could you turn the static void high inside class Brian to non-static?
Sure. He's giving me a hard time about it. Let's delete this and see if we can get things to run now. Yeah, that worked. I don't know if I can expand it a little bit. So now it says hello world, but it doesn't say anonymous inner class. It's using the static class Brian. How about that? Unexpected behavior. I consider that to be a fruitful source of bugs. Because if it's going to give you behavior which you can't predict easily, then, and I got to say, this one fooled me. I could have sworn that was going to print out anonymous inner class, and it didn't. Can anyone tell me why? Because I'm not sure I know why. Yes, sir.
Could you just call b.hi since you declared it at the top?
B.hi.
Inside your enclosing class?
So I went to, what I could do, what I did was I called static class example .b.hi. I didn't make this static, but I could have done, I think. Yeah, why not? So then if you want to just do static class example .b without making a new instance, that's what you're suggesting, right? That should work. Let's see if that's true. Well, it doesn't look like it printed out the anonymous inner class in here. How about that? Why is that, do you think? Suppose I made this a constructor. Constructors don't usually return anything, not even void. But in this case, he's treating it as a method. that returns void. Making a new instance, I'm not sure. It seems to me like it should invoke it, but I'm not convinced anymore.
I think it's the order that it's compiled.
Could be.
Changing the order.
Could be. So static classes are... The whole thing with the nested reference data type, that's really tricky. That's a tricky one. I think that one has thrown me for a loop, pardon the pun. I'm ready to move on to something else, because it really screwed my brain up. That should have run, but I don't know. I've got a bunch more examples like this, but most of them are a little bit more straightforward. Let's see if we can get this one to run. This is called the commando pattern. What this does is it knows how to run itself, and it's got a little do it. And what it does, it takes that command and it calls the run method on it. Let's see if that works. Yeah, it says hello world. So then the question is, how did it get the command? You call get command in here, and then it does the return. And when you look at it, it says new command, and it knows how to run itself, and the command is print hello world. So I get this new command comes in, I call run, and we don't quite know exactly how the run command is going to be implemented, but one thing I can tell you about the command is it has a run method. So it's kind of an example of polymorphism where all the commands know how to run themselves, and all you have to do is provide a run method implementation. And this is very similar to the design pattern for the runnable buttons. You can make any kind of button you want. It implements the runnable interface, and then you have to make it so that the buttons, when you invoke the run method, will do something. So if you said exit, maybe the run method calls system.exit of 0. Or if you said OK, it does the OK thing, or whatever. You know, if you had a touch tone keypad, each button could be assigned a different tone. And then when you click on the tones, you get them out of the speaker. So that when you add all of these buttons together, you'll have the actual tones geographically co-located next to where the new buttons are instanced. So that way you don't have to visit the code in multiple places. That's a critical advantage to the runnable design pattern. This I'll call it command design pattern. Nested reference data types. I'm going fast. I just sort of wanted to review, maybe give you guys a little insight. What about threads and concurrency? Now, this would be chapter 13 in the book. So if you're into, following the lecture and saying, geez, maybe I need a review of that. I've gone through 153 pages worth of the book in terms of review in the last, in the last couple hours. Am I going too fast? No? I'm just sort of giving you the bird's eye lowdown on the stuff that I'm hoping you guys already know. Kyle, am I going too fast? That's no? You don't think so? Okay, so does that mean I can ask you questions? No? Oh, I gotta back off on this a little bit. Maybe I'll do a little bit more inner stuff. Let's see. Anonymous inner classes. There's a good one. Okay, what's going on here, Kyle? Here's a class the anonymous inner class example. And here is a dynamic named inner class which is coming back, and it says dynamic named inner class is called, this is a dynamic named inner class. And when I want to get an instance of a dynamic named inner class, I call anonymous inner class dot get an instance, and it makes a new instance of the dynamic named inner class for me. So that's being created at runtime. And then it says this is a named static, or a static named inner class, right? And the difference between this class and that class is the term static, right? So I can go anonymous inner class dot, this is a static named inner class dot, and then gain access to all the data structures and methods that are contained inside of the static thing, because I don't need to instance that. It exists at compile time. Whereas the dynamic named inner class, I can only gain reference to if I make a new instance of it by calling get an instance. How about this other thing, draw a line? What's that do? Does that actually do anything? I don't think so. I don't think that can work. Right? That's not going to draw a line. Why? How come this doesn't draw a line? Yeah, I don't have any place for the panel to go. You guys ever do any graphic user interface programming? A little bit? Well, how do I make this draw a line? You tell me. You want me to finish the code? I just happen to see it here. Closable JFrame is my, it's actually a swing frame. I'll call it CF equals new closable JFrame, and then CF dot get content content pane, and that returns a container. I should have written that first. Container C equals get content pane. Now what? Yeah, sure. C dot add JP, and now what do I do? We better show it, right? And set the size. How about cf.setSize? And what's a good size for this? It looks like 100 by 100, huh? And then cf.setVisible to be true. And what does that buy you? Oh, there's a line in there somewhere. It sort of looks like a line, right? It has that line look and feel. So what has happened here is the frame is the part where you got the red X where you can click on it and close it. The panel resides inside of the frame. And so now with the graphics context passed into the paint method, you have an opportunity to gain access to a whole bunch of drawing facilities. Right? So if I wanted to, I could say g.setColor, and I could make the line color dot pick a color, red. So now I can build a red line. Let's make this a little larger. So we'll make it 200 by 200, and now we have a nice red line. Oops, didn't work. What happened? Did I draw it in the wrong order? Oh, yes. If you want to draw a red line, you better draw the line while red is set in the graphics context. What did I just do wrong here? Cut and enter, paste. There we go. So now let's try it again. So first you set it red, then you draw the line. Now it's a red line. So order is important. How's that grab you? Good, right? You're now all graphics programmers. Hey, how about those nested reference data types? Are we done with those? I think you've had enough. Unless you want me to torture you some more with nested reference data types. This one's got GUI stuff in it. Maybe it's okay to put that in there. What's a mouse listener? Right, it's an interface. You implement the mouse listener when you're trying to intercept mouse events that come in from somebody who's trying to click on your graphic user interface. The mouse moved, the mouse entered, the mouse left, the mouse down, the mouse up, mouse clicked, all these different mouse events. Well, as it happens, when you implement the mouse listener, you can implement it and provide implementations for when the mouse clicked. Here is an anonymous inner class for the mouse listener with all of the mouse events, and they're all available for you to implement. So when the mouse is clicked, you can do the mouse clicked thing. When the mouse is released, you can do the mouse released thing. And you can add that mouse listener to any container. It's not a particularly interesting example other than the fact that it's syntactically correct. It doesn't really do anything. It doesn't do anything. I don't know what this one does. Let's see what this does. So here is something which implements the runnable interface, which means it has a run method, but we don't know what it does. What does hello run do? We can't know that unless we see the implementation or test it. And in this case, when you hit run, it says hello world. That sounds like fun. I don't think I need to run this, but I will anyway. Yep, there it is. So there you have it, nested reference data types. My homework senses are tingling. So what I'd like to do is assign a little Blackboard homework for you guys to do. Oh, you're going to make me log in again? Really? Let's see now. And we'll hit log in. And we'll do network programming. And we'll get a course content, an assignment, and let's call this homework 1 because it's the first homework. That's what you call the first homework. So what I'd like you to do is download and build the course code, describe any problems that you had. You may not have had any, and that's fine. But if you had them, describe them. Otherwise, report that you didn't have problems. If you want to gain access to our web lectures and get updates, you'll need to go to the course homepage and sign up for the Yahoo group. And you'll also want to sign up and for the change detection. So when the home page is updated, you get an automatic notification. And I'll be hopefully updating the home page with these video lectures regularly, presumably either the same day or within a day, so that you can have these lectures for your later viewing. Let's see now. We'll make this worth 100 points. This will be your first homework. You'll get used to the Blackboard system. If you need an unlimited number of attempts, I suppose that's okay. And then for the due date, what we'll do is we'll set it up so that it's due at 2 p.m. a week from now. And what else? Anything else? Let's make a new tab. Let's go to, I just want to get a URL there for you so that you can find it. I'd like you to check, where is it? Networks. So here's your URL. I'll copy that and paste it right into the homework assignment so that it's handy for you. Let's just make sure that that's in there. Oh, here's your reading assignment. Reading. Please review chapters 1 through 15 and come with any questions that, I mean, you know, what's going to happen is you'll look at something that's a static reference data types and say, oh yeah, I know all about that. And you look at, you know, dynamic reference data types and say, oh yeah, I don't have any questions about that. You'll probably just thumb right through most of this stuff, and that'll get you, there's 45 chapters in the book, so that'll get you right up to and through threads and interfaces and packages, and it'll get you all the way up to serialization, which is kind of where I'd like you to be. So by this time next week, if you have questions and you want me to do a review, I'm very happy to do like a full lecture on any chapter in the book, 1 through 15, and just kind of give you the bird's eye lowdown. I'll be reviewing threads. I don't know if I can do it in the remaining time, but I'll just give you the talk about threads. And then we'll actually do the threads next time. Come with any questions. Come with any questions. Come with questions. Come with questions. And I will, for those who are doing this via distance learning, please feel free to email me with your questions, and I will insert them into the lecture for next week. Let's see, is there anything about this that I need to change? I guess you're all going to get it, so I'll hit submit. Let's see if that works. Yeah, that sort of looks like a homework assignment, doesn't it? Yes? So here's a thought question. What's the difference between multi-threading and multitasking? Yes, sir. That's exactly backwards. You can have multiple threads inside of a single task. But that's sort of a general observation. What's the difference between a task and a thread? No?
A thread is an object of a task.
Well, I'll put it to you this way. Tasks have protected memory, and threads have shared memory. So when you are inside of Windows, which is a multitasking operating system, and let's say PowerPoint crashes, presumably you're not saying hello to Dr. Watson and looking at the blue hex codes spitting out all over your nice clean floor, because it's protected the other applications which are running concurrently by giving it its own memory. So that's very nice. Every application has its own memory. What's wrong with that? Why don't we always run that way? Well, the answer is because it takes a lot of overhead to switch between one task and another, because you've got to swap the memory of that task out in order to swap the memory for the next task in. The process that the operating system goes through in switching between one task and another task is called a context switch. And so because of the effort and the amount of I/O that is required in order to swap the memory out, the act of multitasking in general talks about a high overhead context switch. In comparison with threads, which essentially do the same thing as tasks, except they have shared memory. When you swap from one thread to another, when you switch, it's a low overhead context switch. And that is because you do not have to have protected memory. So protected memory is good and it's bad. It's good because it protects your tasks. It's bad because it has high overhead. Nothing's for nothing. So what happens there is you can have a web server with 10,000 threads serving different jobs, all sharing memory cooperatively because they've all been written by the same programmer, and essentially they play nice with one another. Whereas if you try to do the same exact thing by creating a new process in Windows with 10,000 people coming to your Calvin Klein website because you went live, well, guess what? Your Windows system has just crashed because Windows doesn't want to see 10,000 tasks running. It doesn't care about 10,000 threads, but it surely doesn't want 10,000 tasks. Too much overhead. So multi-threading and multitasking are really different things. Neither represents what I call true concurrency. True concurrency is when two things happen at exactly the same time. With multi-threading, it's one thing after another, and you can establish the priority of the different threads just as you can establish the priority of the different tasks. And you can have a thread scheduler and you can have a task scheduler, and both will consume resources. Those are CPU resources and memory resources. And you have to allocate these things as what the scheduler does through what's called a time slice, which is allocated. So you run using round-robin scheduling one task after another. And so this is one of those things where there are certain fundamental similarities and differences between tasks and threads. And you should know about these things as computer scientists and engineers. You should know these things because they impact your operating system and they impact the performance of your system in general. So I'll put it another way, in a very practical way. If you don't have enough memory and you're running Photoshop, and Photoshop is trying to go from one pixel to the other, and it's sitting out there in virtual memory on your disk drive, what it's doing is it's swapping out a section of the image and swapping in the next section, and that time, that overhead, is allocated to a time slice which then expires. And so what you see it doing is becoming I/O bound, and it goes tick, 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 because you see the disk light flashing on and off, and it makes very little progress. It's just thrashing onto the disk. And so when you have to switch between one context and another, and there's so much overhead that the actual switching takes all your time, you can't make any progress in your job. So that's a real practical way to say, hey, you know what? You need more memory, right? Or you need a different approach to your system. You know, maybe use multi-threading instead of multitasking, or maybe run fewer applications, or use smaller images. So there are a couple of things that you should do that are kind of fundamental when you think about how you're going to construct a system. Yes, sir.
Can you discuss how this relates to multiple cores?
Okay, multiple cores, that's true concurrency. Now, each one of the cores can have their own tasks, and within any task you can have multiple threads. And so with multiple cores, in general, you have to have tasks which are segmentable across the different cores. In general, an operating system has many tasks running at the same time anyway, and they can be allocated to the different cores. And hopefully the tasks don't have to communicate much. And if that's the case, if they do have to communicate a lot, there's going to be some overhead involved in segmenting the tasks across the different cores. Yeah.
And what about virtual cores? For example, like the Intel i5 chips have two real cores and two, I don't know what you call them, but virtual cores.
Yeah, there's architectures out there I don't really know very much about. And sometimes I wonder if it's marketing. Because, maybe that's real. You know what? I shouldn't disparage it. It could be a real thing, and I have to look up on that stuff. So that's a good question. I don't know. I know they have a thing called hyper-threading, and and I know that um, uh, there are always new architectures coming out that people experiment with, and so I'm not real familiar with that one. So let me not give you an off-the-cuff answer. In fact, you know what? Let me study up on that, and I'll get back to you. How's that? Virtual cores. I won't forget. So that's what I have for you for today. Do get the book. I do have a couple of extra copies, but if you want to try the online version, the EPUB version, it's relatively new. Give it a shot and see what you think. Thank you.